Alrighty, so here is the Salmon review, and I already did the buff review, but because I don't know which one you're watching first, I will go ahead and talk you through the same stuff at the beginning here. So when you were trying to identify the conic as a circle, parabola, hyperbola, or ellipse, think about what we know about them and what kind of sets them apart from the others. Well, first of all, the only one of these that would have an x squared and a y squared and have subtraction is the hyperbola, right? And then the parabola has either x squared or y squared, but not both, where the other ones all have both. This would have both, but subtraction. So these two here both have an x and a y squared, and we have addition. But the difference is the ellipse, you're going to have fractions in your equation in the end, and the circle you are not. So in the general form, you could have coefficients in front of the x squared and y squared terms, but it's going to be a circle, they're going to be the same. Okay, so that means that I would be able to divide through either coefficient and just ends up with the x squared and y squared. And in the end, in standard form, it could be like x minus 2 or y minus 3. But then in the ellipse, they would have different coefficients, and so I wouldn't be able to divide through and just get that, but I would have the x squared and y squared, and it would be a positive, okay, or an addition thing. So as we go through this, let's see, we've got x squared and y squared. They have the same coefficient, so in the end, this is just going to be a circle. Here I've got a y squared, but no x squared, so that means this is a parabola. X squared and y squared, we have coefficients, but they're both the same, so I could divide all this out by 4 and not end up with a fraction for the coefficients here, so this is a circle. Here I have x squared and y squared, and there's subtraction, so this has to be a hyperbola. Here I have x squared and y squared, and it's addition, so it's not a hyperbola, it can't be a parabola, it's either a circle or an ellipse, but since the coefficients don't match, and when I divide by 2, I'd have 2 in the denominator here, that means that this is an ellipse. And then x squared and y squared, and coefficients are different, which means that this is also an ellipse. All right, now we're going to identify the center and the radius of each of the following circles. This should be a pretty easy thing to do when it is in standard form. Remembering that your standard form here for a circle is x minus h squared plus y minus k squared equals r squared. So center point here is going to be a positive 7, negative 4. Radius is the square root of 18, but I don't leave it like that, and I don't put a decimal. I'm going to reduce that to 3 square root of 2, and that is the radius. Here I've got 4 as the coefficients, but I can't have a coefficient, so I divide everything through by 4. And when I do that, that gives me x minus 2 squared plus y plus 3 squared equals 64 divided by 4 is 16. So the center point is a positive 2, negative 3, and the radius is equal to 4. Here, center is 0, 0. Radius is the square root of 11. I can't reduce that, so it's just the square root of 11. All right, then standard form equation of circles. Well, given the center and the radius, this should be a pretty easy thing to substitute back in. So x minus h, y minus k, but it's just 0, 0, so just x squared plus y squared. Radius is 9, so that's r squared there, which is 81. Here, x minus 7 squared plus y plus 6 squared equals r squared. Square root of 3 squared is 3. This one was missed a lot on that quiz, right, or this kind of thing. You have the center, so we know how to start this, right? I can start it with x plus 2 squared plus y minus 5 squared equals, but then we got to figure out what the heck is r squared, right? So I can substitute this in. This is my hk, this is my xy. So x minus h, which would give me 2 minus a negative 2 plus 2 squared, plus y minus k, 3 minus 5 squared, equals r squared. So 2 plus 2 is 4 squared is 16, plus 3 minus 5 is negative 2 squared is 4. It's equal to r squared. So r squared equals 20. So r is the square root of 20, but that doesn't really matter because this right here is supposed to be r squared. And so this is just 20. And there is your equation. Here, I need to get this in standard form. So it's going to require me to complete the square. So I'm going to reorganize things. X squared minus 4x plus y squared plus 8y equals, moving that 2 over. Okay, now, completing the square. Again, I think that most of you have the general idea, but something is going wrong for some of you here in some of these places. So we've got x squared minus 4x. I'm going to take half of that. Now all this is going to be equal to 2. Okay, so x squared minus 4x, I take half of that. That's a negative 2 squared. I add 4, so I have to add 4 over here. And then plus y squared plus 8y. Half of 8 is 4. Squared is 16. I added 16 over here, so I have to add 16 over here. So then this becomes x minus 2 squared plus y plus 4 squared equals 2 plus 4 is 6 plus 16 is 22. And there is my answer. And then I want to write the general form here, which means I just have to multiply it all out. So x minus 5 squared is x squared minus 10x plus 25 plus y squared plus 4y plus 4 equals 10. So that's all multiplied out, but now I got to reorganize it into general form. I start with my x squared term, then my y squared term, then my x to the first term, then my y to the first term. Then I have to take this, this, and this into account, and I got to set it all equal to 0. So basically I have a positive 25 plus 4, but then I have to subtract 10 when I move it over. So that's going to give me 19. That's plus 19 equals 0. And there you go. Graphing the circles. In order to graph the circles, I have to have the center and the radius. So here, the center of this one is negative 1, 2. Radius is 4. So negative 1, 2, that's my center. Radius is 4. So keep going back to the center and counting 4 all the directions, and then do my best to make it look like a circle. And that is bad. My other one on the other video is way more impressive than that. Okay, so center here is negative 3, negative 1. Radius is 2. Negative 3, negative 1, that's my center. Radius is 2. Let's see if I can make this one better. That one is definitely better. Still not great. Kind of missed that point, but good enough. All right, center here is 1, negative 2. And then radius is the square root of 10. All right, so I go to 1, negative 2. There's my center point. So square root of 10 is a little bit more than square root of 9. So it's a little bit more than 3. So I go 3 and a little bit. 3 and a little bit, 3 and a little bit. And then sketch it in. All right, there are my circles. Remember, it's not an art class, but you need to make an honest effort that you actually tried to make it circular and you didn't just slop something on the paper. All right, so now I'm going to write, it says write each conic in standard form. So it doesn't tell you which one it is. You need to know that, plus you kind of figure it out as you go along with your work. Oh, you know, my board will decide to respond in a moment. Hopefully. Okay, there we go. There we go. Okay. So we're going to write each conic in standard form. All right, so I have x squared and a y squared, and there's addition, different coefficients. This is going to be an ellipse. You can kind of figure that out along the way, too. So I'm going to reorganize things. 2x squared minus 4x plus 4y squared plus 16y equals negative 6. Okay, move that 6 over. So now I'm going to factor out and complete the square. So I'm going to factor out this 2, which leaves me with x squared minus 2x. Okay, and then half of that and square it, that's a plus 1. Then I factor out this 4, and then I'm going to get y squared plus 4y. Once I factor out that 4, half of that and square it, that's plus 4. That equals negative 6. I've added 2 things on the left, so I've got to make sure I do that on the right. This 1, but remember I have a multiplier, so I have to take that 1 times 2, and I'm adding 2. I added this 4, but there's a multiplier, so I have to do 4 times 4, which is 16, before I add that together. Okay, so then that gives me 2 times x minus 1 squared plus 4 times y plus 2 squared equals, so this is going to give me, when I add all those up, that negative 6 and 16 is 10 plus 2 is 12. So then I'm going to come in and I'm going to divide everything through by 12. So that's going to leave me with, this reduces down, the 2 and the 12 is going to give me x minus 1 squared over 6 plus the 4 and the 12 reduces down to 1 over 3, so y plus 2 squared over 3 equals 1. Okay, so I'm going to rewrite that same thing, but I'm going to move it over because I feel like I've used too much space there. Maybe my board doesn't want to respond again. Okay, so I'm rewriting the same thing, I'm just moving it over. So this gives me x minus 1 squared over 6 plus y plus 2 squared over 3 equals 1. I don't think I moved it over that much. I think I wrote bigger. All right, so there's that. So now when I look at 19, this one is a parabola, okay? Still got to complete the square, but when I complete the square for the parabola, I'm only completing it with the x, so the y gets moved over too. So this is going to give me x squared minus 4x equals, I'm going to move that 4y over, so positive 4y minus 24. Then I'm going to complete the square, so x squared minus 4x, half of that and square it, you get 4. Alright, I got interrupted and it's been like 20 minutes, so I don't have a clue what the last thing out of my mouth was. But we've moved over the 4y and the 24, and so I completed the square on the, well, the left. I'm not complete because over here I had the 4y minus 24. Since I added 4 over here, I have to add 4 over here. So then this becomes x minus 2 squared equals 4y minus 20. But then I have to factor out that 4, so x minus 2 squared equals 4 times y minus 5. There is my parabola. Alrighty, so here, got this minus going on, so that means I'm going to have a hyperbola. Let's start with my 9x squared, then minus 90x, then my minus 4y squared minus 24y equals a negative 153. Okay, so You've got to factor it out a lot like we did here, but there's an extra thing you got to be really careful of, and I saw a few people mess this part up too. So I got to factor out the 9, so I get 9 times x squared minus 10x. So I'm going to take half of that, that's negative 5, and square it, that's plus 25. Okay? Then I have to factor out this 4, but I'm factoring out a negative 4. Since I am factoring out a negative 4, that leaves me with y squared plus 6y. Let that sink in for a minute. Factoring out the negative, this changes the sign here. And then half of 6 is 3, squared is 9. That's equal to negative 153. All right, so now, got to complete this. I added this over here, but I have a multiplier. So 25 times 9, think about you have 9 quarters. You have 9 quarters, you have $2.25. So I add 225 over here. I added this 9, but I have this multiplier. 9 times a negative 4 is negative 36. So I'm actually subtracting 36 over here. So I have to subtract 36 over here. Then I get 9 times x minus 5 squared minus 4 times y plus 3 squared equals, okay, and then when I combine all of this together, right, this is going to give me a positive 36. So then I divide everything through by 36. I reduce this to become x minus 5 squared over 4 minus, reduce this to get me y plus 3 squared over 9 equals 1. And there you go. All right, on the back. Maybe, when it responds. So I'm going to find the following data for the hyperbola and graph it. Okay, so it told me it was a hyperbola. If it doesn't tell you that, then you should still know by the equation. So whether or not it is a horizontal or vertical major axis, it's really not the major axis for hyperbola, it would be the transverse axis. So since the x term comes first, that means it is horizontal. My center is negative 1, negative 2. Remember, a for a hyperbola is not necessarily the bigger one. It's the one that comes first. So 9 is a squared, so a is 3. B is 4. For a hyperbola, c squared equals a squared plus b squared. If this is subtraction, this is addition. So that's going to give me 9 plus 16, which is 25. So C is 5. So I'm going to go ahead and graph some things here. Center is at negative 1, negative 2. Right, I've got the A, which goes along my transverse axis, which again is not necessarily the biggest number, but it does give me my vertices. And I know this is horizontal, so from C, I count 1, 2, 3. It's a vertex. 1, 2, 3. That's a vertex. Co-vertices, 1, 2, 3, 4. 1, 2, 3, 4. So what those are going to give me, or what that's going to help me with, is to find the corners of my rectangle to get my asymptotes. Then you would want to use a straight edge, and I would suggest making them dotted, but I'm not going to make them dotted just because that makes it harder for me up here. I can't use my cheat tool, and without my cheat tool, it's not even going to look like a line, so. There. That's one asymptote. The next one. Not sure that those look 100% great, but I think that's good enough. I have this rectangle that gets created here. You could draw in the rectangle if you wanted to. You don't have to, but get your dotted lines or whatever. So I have my vertices, which I can get from the graph, or I can understand the fact that my x value is changing from the center and my vertices come from A. So this would be -1 minus 3, which is -4, -2, -1 plus 3, which is 2, -2, and those should be the points that I have plotted if I did it correctly. My co-vertices would be these up here, so it's the change. My y is changing, so this would be -1, and then -2 minus 4, which would be -6, and -1 would be -2 plus 4 is 2. And there are my co-vertices here and here. My foci, that's where I use C. Okay, so from the center point, C is 5. So go 1, 2, 3, 4, 5. There is a focus. And then 1, 2, 3, 4, 5. Here is another focus. So again, my x is changing. So -1 minus 5 is -6, -2. -1 plus 5 is +4, -2. I had you mark out that half there. So your focal chord is 2b squared over a. So it's going to be 2 times 16 over 3. So that gives you 32 over 3. That's your focal chord. Now the reason it said 1/2 is because really that's all you're counting. Like the length of the focal chord is that 32 thirds, but half of it is what you count from the focus. So half of the 32 over 3, that's 16 thirds. You can think of it that way, or you can just go back and look. All right, so if this would give me 10 2/3, so half of that is 5 1/3. So I would count, go 1, 2, 3, 4, 5 1/3. 1, 2, 3, 4, 5 1/3. Yeah, hard to estimate when I'm not even a graph there. And then 1, 2, 3, 4, 5 1/3. 1, 2, 3, 4, 5 1/3. Right there. Okay. And so then I'm going to graph this. Start at the vertex. These points you have to plot, you lazy people. Plot those, and then you're going to go through that and try and hit it better than I do. Oh my gosh, I did the exact same thing. My pen's not calibrated very well. There we go. Well, I still kind of hit the exact same spot no matter what I do. Oh, shoot. There, that's a little bit better. Well, I'll just make the points bigger. Estimates anyway. There we go. Something like that, but a whole lot better. Easier to do on a piece of paper. So then the last thing I need to do are my asymptotes. So that's a pretty easy thing to write. It's an equation of the line, but the first thing you do is take your y term, whatever it may be. In this case, it is y plus 2. That's equal to plus or minus a slope that we'll fill in a minute, and then our x term, x plus 1. Not squared or anything, because this is the equation of a line. So remember, the slope is either a over b or b over a, but here's the a, which is your horizontal, your b is your vertical, and its slope is always a rise over run, so it is going to be b over a. B is 4, a is 3. You would reduce it if you could. We can't reduce that, so it is just 4/3. Alrighty, so now we are going to graph an ellipse. I'm going to erase this. I must have circled that when I told you to fix it. Okay, so for the ellipse, I've got x term always comes first, but then the a squared is the bigger one, and that tells you if it's horizontal or vertical. So a squared is 25, so a is 5, b is 2. And since the bigger number is under x, that makes it horizontal. And this one is a major axis. My center is -3, 1. For an ellipse, c squared is equal to a squared minus b squared. This is addition, this is subtraction. This is going to give me 25 minus 4. So c is the square root of 21. Okay. So my major axis length, major axis is 2a, so it's 10. Minor axis is 2b, which is 4. Let's go ahead and plot some stuff. -3, 1 is my center. And this goes off the graph pretty decently too. I can go ahead and get my vertices. This is horizontal. And so from the center, I'm going to go to the right. 1, 2, 3, 4, 5. That's a vertex. 1, 2, 3, 4, 5. That's a vertex. So my x value is changing. I would take my center point and subtract 5. So -3 minus 5 is -8, 1. -3 plus 5 is 2, 1. And then my co-vertices from the center, b is 2. So go in either direction. There are my co-vertices. So my y is changing from my center point. So this is -3, 1 minus b. So that's -1, 1 plus b, -3, 3. And those are the points that I already have plotted. So my foci, those are going to go along my major axis. So that is the x that is changing. I would take the -3 and subtract the square root of 21, 1. And then -3 plus the square root of 21, 1. Notice that this is exact, so is this, so is this. I do need an estimation to be able to graph it. So this is about 4.58. Okay, but your answer is the square root of 21. You can jot that down so you have something to graph. So from the center point, I'm going to go to the right. 1, 2, 3, 4.58-ish. 1, 2, 3, 4.58-ish, that right there. I need the focal chord length, so that is 2b squared over a. So that is 2 times 4 over 5. So that's going to be 8/5. Right? So 8/5 would be like 1 3/5, or you can think about if I really just want half of it to count from here, half of 8/5. Oh, I guess I'm going to put my answer here. 8/5 is the length of the focal chord. What I count is not 8/5. What I count is half of that. Half of 8/5 is like 8/5 times 1/2. So it'd be 8/10. Well, 8/10 I can estimate. 8/10 is about right there, right there, there, right there. You must plot those points. Okay, people keep leaving them off. You need to plot them. I need to be able to see them. So if they're teeny tiny and then you draw your line over them and then I can't see them anymore, that does not count. They don't have to be ginormous, but make sure I can see them. Okay, so then I'm going to draw in my ellipse. I'm probably going to make this one dotted because even dotted doesn't look that good. And I know when it goes off the graph like that, that is an issue. I will make sure that it makes it even look more flippy. You don't really want it to be super pointy, but I think part of that has to do with the fact I don't even know where my grid is, but that gets you the right idea there. All right, so then we're going to graph a parabola. So the vertex here is at -3, 1. Remember that 4p is equal to -8, so p is a -2. A couple of things here. It doesn't really ask you which way it opens. However, Y is squared, so you know it opens left or right. This is negative, so you know that it is left. So I can go plot my point, my vertex. 1, 2, 3, negative 3, 1. There's my vertex. P is negative 2, so that gets me a whole bunch of stuff. First of all, I know which way it opens, so P, I can count 2 this way. This gets me my focus. Count 2 this way. This gets me my directrix. Okay. So, and then this is my axis of symmetry. So my axis of symmetry is horizontal, therefore it is y equals 1. My directrix is vertical, that is x equals negative 1. My focus point, okay, if P is a negative 2, I'm at negative 3 on the x-axis. I go 2 more to the left. So it's negative 5, 1, plus that's what I had already plotted. Focal chord length, there's no, it's not 2b squared over a or anything. It is the absolute value of 4p. So it's the absolute value of negative 8, so it's just 8. So from here, I count 1, 2, 3, 4, and here 1, 2, 3, 4. That gets me the points that I need, and then I can draw in my parabola. Ugh. Okay, maybe I can't do that with that. I can't do it at the angle I need. It's my weird stupid pen. And I know I could calibrate it. It's really not going to help it any, because then it just causes other issues. All right, and there we go. So make sure that you know all of your pieces. Make sure when you complete the square, you're doing those things correctly, that you're factoring out the right numbers, and that when you're adding to both sides, you are using your multipliers that you need. Okay, so that is it for your Salmon review.